Okay, today's lesson is harmonic motion. And basically, the equation for a harmonic motion, which is sinusoidal, is the word, means the graph is doing this. I mean, it's looking like a sine graph. That was a really bad example right there, sorry. Okay, so let's get rid of that one too. Boop. All right, so let's work through this problem, and you'll see how it all works out. It says the wheel with a radius of 2, so this is 2 centimeters long, is rotated counterclockwise, which means it's going in this direction, y'all. Okay, 3 radians per second. We'll come back to that in a minute. A free hanging rod, 10 centimeters long, so this is 10, is connected to the edge of the wheel at point P. So it's stuck right there at that point and remains vertical as the wheel rotates. So the wheel's going to rotate. It rotates backwards, and that point P moves to here. The rod is still hanging down, okay? And then point P is going to rotate to here, and that rod's still hanging down. And point P moves to here, and it's still hanging, okay? So this tip is rotating up and down and around and back. It's making the same circle that the wheel is, all right? Well, we want to graph that. So at the beginning of time, it's right here. Time goes by, and it wrote this point E, all right? So this is really, E is what we're talking about. It's down here at negative 10, because this is 0, so this is hanging at negative 10. As it rotates, this went up 2, so the point went up, the tip went up 2, so it went to negative 8. And then when it gets to this point, the tip rotated back, so it's the same, it's back to 10. And then when it gets down to here, it rotated from 10 down here to negative 12. And then when it completes the circle, it's here. So if you sketch the graph, guess what? It looks like a sine graph. It started in the middle and went up. So that's how I know it's a sine graph. Okay, so the period. Well, they tell me it's 3 radians per second. So 3 times the period, the time it takes to go around the circle, is 1. Okay? So if you take, there's 2 pi radians divided by 3, that's going to give you your total time for one cycle. To find the value of B, remember that your period is equal to 2 pi divided by B. And T was that, so that's equal to 2 pi over 3. So B is equal to 3. The amplitude is how high to go up. It went from negative 10 to negative 8, back down. Here's your center line. The amplitude is 2. What are the coordinates of E at the start? Well, it would be 2, negative 10. Okay, we want to write an equation for E. Now remember, the equation's not dealing with X. That's an X value. We want T. This is in terms of T. All right, so it's Y equals, the amplitude was 2. It's a sine graph because it started in the middle. We said B was equal to 3, and it starts at negative 10. All right, not too bad, pretty easy. Because we know all our graphs, that's why we did graphs first. Okay, now it says use the equation to find the first time that the tip of E is at a height of negative 9. All right, so negative 9 is right here. Now remember, this is not a straight line. It's not halfway in between this time and this time. It's a sine graph. All right, so we're going to say negative 9 is equal to 2 sine 3t minus 10. If I add 10, you get 1 is equal to 2 sine 3t. Divide by 2, and you get a half equals the sine of 3t. Well, when does the sine equal a half? We know our unit circle, so we know that that's pi over 6 is equal to 3t, because this has to equal pi over 6. So t is equal to pi over 18. That's kind of interesting. That's in seconds, not an angle. So this thing, when we, right, this is 2 pi. This is pi after pi seconds. And oh, no, is that right? No, if it's, that'd have to be, no. I'll have to come back and relabel that. I'll have to think about that. Because this is time. This is pi over 18. Come back and think about that. Come back. All right. What will be the height at the time of 5 pi over 6 seconds? 5 pi over 6 seconds. So your equation is y equals 2 times the sine of 5 pi over 6 times 3 minus 10. So that becomes 2 times the sine of 5 pi over 2 minus 10. The sine of 5 pi over 2, well, where's 5 pi over 2? This is a half. This is 3 halves. This is 5 halves, so I'm right there. The sine is 1. So 2 times 1 is 2 minus 10 equals negative 8, which means it's back the top of its peak up here at 5 pi over 6. So yeah, these labels are wrong. Eek, take these off. What did we say? The period was 2 pi over 3. So this point is 2 pi over 3. This is pi over 3. This is pi over 6. That makes more sense. And that's 5 pi over 6. It's back at the top again. There we go. That makes sense. Whew, straighten that out. All right, let's do another one. All right, a buoy oscillates in a simple harmonic motion as the waves go past. The buoy moves a total of 3.5 feet from its high point to its low point, and it returns to its high point every 10 seconds. Find the equation that describes the motion of the buoy. Okay? Ooh, so it starts at its high point. So it starts up here, it comes to the center line, goes to the low point, comes back to the center line, goes back to the high point. The graph that starts at the top is the cosine, not the sine. So I'm going to use the cosine. My amplitude, they told me it's a total of 3.5. So 3.5 divided by 2 is 1.75. So y equals 1.75. The period they say is 10 seconds, but we need to find b. So 10, so basically this is 10 seconds. Okay, this is 5. This is 2.5. So 10 equals 2 pi divided by b. So b is equal to 2 pi divided by 10, which is pi over 5. So you get pi over 5 times t. And there's no displacement. So there you go. Perfect. All right. Now, one more problem. There's a spring. He's hanging here, and it says by an upward push. You could have pulled down on it. You could have pulled down and it went this way. Instead, we pushed up. So they pushed it. It takes 5 seconds for it to complete a cycle of moving from equilibrium position of 8 above, then dropping to 8 below, and finally returning. So he's starting here. We pushed on it. It went up to 8, came back to equilibrium, went down to 8, came back to equilibrium. That takes 5 seconds. Okay, so this is 8. This is negative 8. All right. That looks like a sine graph because it's starting in the middle. So our equation is y equals, and we know it's a sine graph, and the amplitude is 8. But let's answer these questions. Independent variable is time. Dependent is height. Amplitude is 8. What's the period? Well, they told us it takes 5 seconds. So 5 equals 2 pi over b. So b equals 2 pi over 5. So this is 2 pi over 5 times t, and there's no displacement because it's starting at equilibrium. Okay, use the equation to predict how high the weight after 3 seconds. So 8 times the sine of 2 pi over 5 times 3. And you put that in your calculator. Make sure your calculator's on radians. Hang on, I'll do this right now. You're writing, so that's 6 pi over 5. The sine of 6 pi over 5. And my calculator's in degrees, so I'm going to get the wrong answer. Set up, go down to angle, radians, better. Okay, now I get negative 0.587, and I multiply times 8, and it's at negative 4.7. Are we doing inches, centimeters? Must be centimeters. So after 3 seconds, it's down here, which is about right, because this is 2.5 seconds, right? So we did pretty good. All right, in the first 5 seconds, when will the height of the weight be 4 centimeters below equilibrium? So at this time, it's going to be negative 4 is equal to 8 sine 2 pi over 5t. You divide by that, and you get negative 1/2 sine equals the sine of 2 pi over 5t. Well, we know the sine is equal to negative pi over 2, negative 1/2 at 7 pi over 6. And that equals 2 pi over 5t. So multiply by the reciprocal. Your pi's cross out and you get, oh, that's t, equals 35 over 12 seconds. That's 35 divided by 12 is 2.9 seconds. Which makes sense, because at 3 seconds it was further down, right? We did good. All right, that's all there is to it. Practice, practice, practice.